Pre-calculus. Today we're going to look at rational exponents. Again, this is still a unit from Algebra 2. Rational exponents. Notice the first 5 letters of the word rational spell out ratio. So ratios, comparison of two numbers by division. So when you see rational, you should be thinking fraction. We're going to write radicals as fractional powers by using the power on the radicand as the numerator of the fraction and the index number as the denominator of the fraction. So the general rule is when you see the nth root of something, nth root of a base b to the a power, you are now allowed to write it as b to the a divided by n. And what's going to happen is that the power is not going to be divisible by the index number like we're used to. So we're going to learn how to write it as a fraction power. First part is learning target is how to convert between radicals and rational powers. So when you're looking at your screen, you notice on the first part, I've just given you 3 different radicals. The square root of 5 is the first one. We are going to convert from a radical to a rational power. And so based on what we see, we know the index in number 1 is a 2. We just see 5. 5 is raised to the first power. We, from the past, would always say divide the power by the index, and when we couldn't, we would just leave the radical alone. So it depends on the directions. If it's just asking you to write it in simplest radical form, then this is simplest radical form. But if they're wanting you to practice a conversion between a radical and a fraction power, then you would go ahead and write down your base, which is 5. You would take the power on the radicand and use it as the numerator of your fraction. And then you would take the index number and use it as the denominator. And so, very simply, when I see the square root of 5, it's the same thing as 5 to the 1/2 power. Question 2. Cube root of 4. 4 is raised to the first power. You're going to take your base or your radicand of 4. Same thing for number 1. You're going to divide power on your base by the index of your radical. These two are equal. The cube root of 4 is the same thing as 4 to the 1/3 power. The cube root of 4 is the same thing as 4 to the 1/3 power. Example 3. The 4th root of 8, a to the 2nd, b to the 3rd. Remember, numbers have powers as well. When you don't see one, it's always a 1. You're going to rewrite your radicand. We're going to do each piece separately, though. We'll start with the 8. You're going to raise it to the 1/4 power. Then you're going to use your letter a, variable a. 2 divided by 4. Then bring down your b. And 3 divided by 4. And then, as always, please simplify when you can. Now, the 4th root of 8, or 8 to the 1/4, you can actually type this in your calculator, but when you do so, you're going to see that it gives you a decimal, kind of messy decimal, so it's actually better just to leave it like it is. So my comment about simplifying your answers really deals with if this had been a whole number, you would definitely want to give me that. And then on this fraction, 2/4, we know a more reduced fraction answer for that, so we want to go ahead and call it 1/2. And then you'll drop down your b to the 3/4. And so remember, the directions on this top would say something like convert between radical and rational form. This is the rational exponent answer, and these two are equivalent. Now, let's go backwards. Now let's convert between rational power and radical, or into radical. 4 to the 3 halves. You could actually type this in your calculator, and you would be able to get the simplified answer, but let's go with conversion to radical first, and then we'll convert, or then we'll simplify. So you'll drop your 4 down. Remember, the numerator of the fraction actually is going to stay on your base, so it's going to be 4 to the 3rd, and the denominator of your fraction is going to become the index number. And then on problems like this, if you can, you're going to simplify. 4 to the 3rd power, and that is 64, and the square root of 64 is 8. But like I said, take a moment, just take a second and type in the original problem on your calculator right now, and just make sure that you get the same thing. Okay? Alright, example 5. We're doing x to the 4/5. You're going to drop your x down, drop your power. The denominator becomes the index number. Converting between fraction power and radical. We can't break down x to the 4th any farther in order to be able to take a 5th root of it, so this is the best answer. So when it says convert, that's pretty much the rule, making sure you understand that these actually are the same thing. Okay, second part of the notes is we're going to look at some properties from Algebra 1 and Algebra 2. Properties of rational exponents are actually the same thing as properties of integers. So once you know that it works for whole numbers, it's going to work for fractions as well. So these rules are the same from the ones you've seen in Algebra 1 and Algebra 2. Number 1, product rule. Product rule allows you, when you see a multiplication problem, and we're dealing with monomials, like it could be variables, numbers, everything mixed together, and there's a times sign in between, you're going to multiply coefficients, you're going to add powers on the same variable. So in order for you to understand how to apply properties to the rational exponents that we're learning currently, you are allowed to use all the properties of integers that you've learned in the past, which makes it good. Number 2, power rule. Well, it's going to work the same in this section. If I have a monomial and I see a big parentheses and a big power on the outside, I'm going to multiply that power outside parentheses by all the powers on the inside. Quotient rule. Quotient means division. So when I see monomial divided by monomial, I'm allowed to divide coefficients. Remember, coefficients, number being multiplied by the variable. I'm allowed to divide coefficients and subtract powers as long as it's the same variable, same letter. And then rule 4, negative power rule. If I have a letter or a number raised to a negative exponent, I can't leave a negative power in my answer, so I'm going to have to change the position of the term with the negative power. For example, if the term is on top, then before you call it quits and give me an answer, you need to move it to the bottom. And it works vice versa. So if you notice it's on the bottom, you need to make sure you move it to the top. When you move a term with a negative power, the power becomes positive after you move it. Okay, now we're going to get into some simplifying problems. Simplify means give me the best simplified reduced answer that you can. Okay, On number 1, it says 8 to the 1/3 times 8 to the 2/3. What I want you to notice is that this problem does not have a variable, okay? Because it does not have a letter, these are not coefficients. The rule for multiplication says to multiply coefficients and add powers as long as it's the same variable. I'm going to make an extension to that. You're going to add powers as long as it's the same base. So 8 is the same value, but it is not a coefficient. This is a common mistake. I have people all the time want to multiply these together and call it 64. Again, you have to follow the rule precisely, exactly as it's worded. So it says say multiply coefficients. Because of that, we're not supposed to multiply the 8s. We're supposed to bring down the base. Okay, and I actually don't need to be using an equal sign because these are not equations. So 8 comes down, and then because it says times, I'm going to use the product rule, which is adding powers. So I'm adding 1/3 plus 2/3. When I add fractions, I have to have a common denominator, of course. I already do, so I add 1 plus 2 to get me 3. 3 divided by 3. Well, 3/3 is better known as 1. So that's 8 to the 1st, and so really that's just 8. Okay, and it'd be better if I'd written it underneath here. Really, you need to write the problem and work underneath. And I'll do that on the next one. I just didn't have room. Okay, number 2, 5 to the 1/2 raised to the 4th. Well, again, I don't see a variable, but I do have a base. This is the base. I have a power on the base, and then I have another power. This is called the power rule. You are supposed to bring down the base first, and you are to multiply the power on the inside by the power on the outside. So 1/2 times 4. Remember, when you're multiplying fractions, you are going to multiply straight across. I'm just going to make 4 a fraction, so it's going to be 1 times 4 is 4. Of course, 2 times 1 is 2. So 4/2. Well, 4 divided by 2 is 2. So you're going to write it like that. And then you're going to simplify, because we know 5 squared is better known as 5 times 5, or 25. So this is the best answer. But you still have to show that step. Okay, number 3. 9 to the negative 1/2. Again, I don't see a variable involved, but I do have a base, 9, and I don't like that it's raised to a negative exponent. So what I'm going to have to do is use the negative power rule from the last slide, and that says change the position. So I'm going to move this entire problem underneath the fraction bar. Now when I move it, that negative 1/2 becomes positive 1/2. But because there was nothing left on top, I had to put something there, and that is a placeholder of 1, because dividing by 9 is the same as 1/9. And so 1/9. Let's see, it's 1 divided by 9 to the 1/2. Okay, the directions does say to simplify, of course. I keep saying that, bringing it back to the same comment. But I want you to get it in your head. I don't want you to stop too early. 1 divided by 9 to the 1/2 is the same thing as, I'm going to convert the fraction back to a radical, because we've been working with radicals lately, and you may be probably more comfortable with that. So 9 to the 1/2 is the same thing as the square root of 9. Okay, coming back up here, I have 1 over the square root of 9, just kind of recopying it so we can see it. And the square root of 9, again, we want the principal square root, so it's just the positive version. Square root of 9 is 3. 1/3 is a simplified reduced fraction, and so that is the answer to 9 to the negative 1/2. Also, a quick reminder, I said this before, but you actually can type this in your calculator just to make sure that when you show me your steps in your work, you're getting the same thing. When you type in 9 to the negative 1/2, your calculator should say 0.3 repeating and 1/3 is equivalent. But again, these steps have to be shown. Question 4. 7 to the 3/2 power divided by 7 to the 1/4 power. Again, I don't see a variable. It does appear to be a quotient rule, but because there's no letter, I can't divide coefficients. There is no coefficient. So you're going to drop your base down, which is 7, and the rest of the quotient rule says to subtract powers. So, kind of modeling how you're thinking about it, you're going to take the top fraction on top, 3/2, you're supposed to think subtraction, subtract 1/4. I cannot subtract fractions until denominators are the same. 2 and 4 both divide into 4. Drop my 1 down. 2 goes into 4 2 times, and 2 times 3 is 6. 2 divides into 4 2 times. 2 times 3 is 6. 6/4 is the same as 3/2. Now that the denominators are the same, you can subtract 6 minus 1 to get you a 5. And then you're going to keep the same denominator. So 3/2 minus 1/4, all of this is just to show you like how the calculator works it out. But it's 5/4. You're going to put 5/4 here. Okay, again, it says simplify, so we have to keep going if we think we can. So one thing, if you're not sure, you can always revert back to radical form. I suggest you do that. Bring the 5 down as the power on 7, and it is a 4th root, so 4 is your index. And then you can even take it one step further, and don't leave like a number raised to a power. Go ahead and use your calculator and evaluate 7 to the 5th. 7 times 7 times 7 times 7 times 7. You'll get this big number, 16,807, it looks like. And then on your calculator, you might want to check to see, can I really do that? Can I do the 4th root of 16,807? So if you'll type it in, if you get a whole number, you definitely want to write down the whole number. If you get a decimal, do not. So the 4th root of 16,807, I just typed it in. It's 11.38603,593 and so on. And so I'm going to leave it like this. Okay, I guess I actually should check to see if it's divisible by a power of 4. Let me do that really quickly. So 16,807 divided by 2 to the 4th is 16. Divide that by 16. It does not go evenly. Then try the next power of 4, which is 81. That doesn't work. The next power of 4 is 4 to the 4th, and that's going to be 256. So let's see if 16,807 is divisible by 256. Nope, does not work. Okay. But if you did find one, you would want to do what we've done in the past, break it down into factors, and go from there. This section has a lot of different directions, so again, you're going to need to be really careful and make sure that you're following those. Converting, just going from one method to the other, one form from one form to the other. When it says simplify, you want to apply all the rules that you're currently learning and rules that you've already had in the past, but then make sure you give me the absolute best answer you can. Alright, let's try 4 more. Number 5, negative 32 to the 4/5. So, I'm going to drop my base down. I see a fraction power, so I'm going to change it over to a radical. I'm going to keep the 4 on the base. The 5 becomes the index. Okay, I'm going to drop my fifth root down. Underneath, I'm going to evaluate. There we go. Evaluate negative 32 to the fourth. So when you type it in your calculator right now, you want to make sure that you're using parentheses around the negative 32. Raise it to the fourth power, and then write in your answer. And it is a big one. 1, 0, 4, 8, 5, 7, 6. Then you want to check to see if you actually can do the fifth root of that number. Fifth root of 1,048,576. When you type it in, it does work. It's 16, meaning that 16 to the fifth power is this number. Okay. Question 6. I finally get to a problem that has a variable involved. I have a coefficient now. Coefficient is 16, y to the negative 8. I see a power on the inside and a power on the outside. Actually, I see 2 powers. There we go, 2 powers on the inside. Don't forget, numbers have powers as well. We just normally don't write them. If it's a 1, we don't write it, but it's still there. So we're going to use the power rule. Power rule says bring down your base. Let's start with 16. You're going to multiply 1 times negative 3/4 and call it negative 3/4. Okay. You're going to drop down your y. You're going to multiply negative 8 times negative 3/4. Again, you can use your calculator if you need to. That's going to be 24/4, and that answer is going to be 6. This is not simplified, so your next move should be to notice that 16 has a negative power, so this entire piece right here that I'm circling needs to go to the bottom of your answer. So we're going to put it underneath that division bar, and we're going to call it 16 to the positive 3/4. Okay, y to the 6th is going to stay on top where it is. Now, when I look at this answer, or this step, I notice that this is not simplified for a couple reasons. Number one, I have simplified the negative, but I have a fraction power, and a fraction power, that's our entire unit or section today. When I see a fraction power from now on, my brain has to think radical, and we are not allowed to leave radicals on the bottom of division problems. So this is not simplified. One thing you can do is see if turning this into a radical will help you simplify it. We can try that, just like we have in the last few problems. You can change that fraction power over to a radical, put 3 on top, or 3 as a power, keep the 4 as your index, and evaluate that. 16 to the third. Okay, so let's see if this is going to work for us. If it doesn't, we might have to go back and rationalize. Sixteen to the third is 4,096. And then check and see if you can actually do the fourth root of 4,096. If you can, and I just did it, and it looks like it works. This entire problem here becomes 8. So 8 times 8 times 8 times 8 is 4,096. You're going to put an 8 here in its place, because 8's way more simplified than that is. And now I know my answer is simplified because I don't see a negative number, I don't see a imaginary number, I don't see a radical, there's no fraction, there's no decimal, and now we have to add there's no fraction power to the list. So all those things we check for before we call it quits on an answer, no negatives, no fractions or decimals in a division answer on the bottom. No imaginary number needs to be left on the bottom. No radical, and now no fraction power. Fraction powers are the same as radicals. Okay, number 7. Fourth root of x to the third divided by eighth root of x to the second. Well, when I'm dividing, I can use the quotient rule. The problem here is I have different index numbers. So a good thing to do in this scenario, don't quit and say, well, it can't be done. You want to try to see if you can convert it to a fraction power and see if that will help you. So on top, you're going to get x to the 3 divided by 4. X to the 3/4 is the same thing as the fourth root of x to the third. X to the 3/4. Denominator, eighth root of x squared is the same thing as x to the 2 divided by 8. Okay. Oh, but 2 divided by 8 simplifies, so we should write it like this. Let's go to the top, copy it down. Let's go to the bottom and change 2/8 to 1/4. And now we can use the actual quotient rule from algebra. Quotient rule again says divide the coefficients. Because I see a variable, there are coefficients. I can divide 1 by 1, it's still 1. I can drop down my base, which is x, and I can subtract 3/4 minus 1/4. 3/4 minus 1/4 is 2/4. And we know a better answer for that, x to the 1/2. Okay, and then I haven't said this in the last examples, but it's always a good idea to remember this too. Most of the time, if they give you a radical problem, the problem has radicals in it, they really want you to write the answer in radical form. So you actually can just say, well, that's the same thing as the square root of x. These are both the same thing, but chances are that's how the key is going to be set up. So the general rule of thumb is when they give you a problem that has radicals, they expect you to give them the radical answer. When the problem has fractions in it, they expect you to give a fraction power answer when you can. All right, last one for today. We've got x to the 1/4 divided by y to the negative 3/4. Everything's being raised to the 12th power. I notice that the variables are different, unfortunately, so I cannot subtract these powers. Quotient rule says that these bases have to be the same. So I can't really do anything in division. I have a couple choices. I can take the 12 and use like a power rule and multiply it by both of these. So I think I'll start there. Another option is to just go ahead and move this to the top. So I'm going to choose the power rule first. So I'm going to drop down my x, and I'm going to multiply 1/4 times 12 over 1. That's going to be 12 over 4, which is the same thing as 30. Again, you can use your calculator if you need to, but 1/4 times 12 is 3. Draw your division bar, drop your y down, and now multiply negative 3/4 times 12. Negative 3/4 times 12 over 1 is negative 36 over 4, and that becomes negative 9. Okay. Again, my variables are different, so I can't subtract these numbers. This is not simplified though because there's a negative exponent, so I'm going to bring down my x to the third, and I am going to change the position and move the y term to the top. So it's now going to be y to the positive 9. And that is a good answer. Okay, and that's how you convert between rational and radicals. And then there's all kinds of the rules, and there's all kinds of different types of problems they'll give you. Just make sure that you simplify as much as you can.